Okay, so I'm going to walk you through this example problem that's in the notes. It says a ball is kicked with an initial velocity of 25 meters per second at an angle of 40 degrees from the horizontal. So we're going to determine a couple things. So the first thing we need to do is draw this situation out like that. And then next, the first thing you have to do is figure out the components of the velocity, like I've done here. So my x component is about 19 meters per second, and my y component is about 16 meters per second. Okay, so now that I have those two components of the velocity, I can solve for everything else. So from here, what we need to do first is figure out the time that it takes to get both to the top and all the way. Right, so let's do that first. So starting with that initial VF equals V naught plus AT equation, I can solve for the time to get to the top, right? And that gives me 1.6 seconds, right? So it takes 1.6 seconds to get to the top. But I need to know the time it takes to get the whole thing also, right? So to get that, all I would have to do is double it. So it takes 1.6 seconds to get to the top, and it takes another 1.6 seconds to get all the way back down for a total of 3.2 seconds. So now we can go back to part A where we find the peak height of the football. Okay, so this is that delta y equation for position as a function of time. And so we're going to use for these two times the time it takes to get to the top, right? Because we're trying to find the peak height of the football. And so where the peak height is, the time is 1.6. If we tried to plug in 3.2, the height would be 0 because it's gotten all the way back to the ground, right? So the times that we're going to plug in are the 1.6. That's going to go in these two times. And so something else to notice too is this is a negative sign now. This thing is negative because in our coordinate system we're calling up positive and down negative, right? Because all these numbers before over here, these were positive, like that was velocity, that was positive. So that means if gravity is pointing down, that needs to be negative, so that makes this sign negative. So plugging in and solving everything, putting that 1.6 in here and making sure to subtract and not add, I end up with the height being 12.8 meters. Okay, so the last thing we want to get is the horizontal range of the football. And again, when you get in the x dimension, that's easy, right? Because this isn't accelerating this way. It's only accelerating up and down, right? So there's only one equation involved in the x dimension, and that's this one. The velocity is displacement over time. So remember, this velocity is our x velocity from right here. And the time is going to be the total time, right? Because now we're talking about the time it takes to get all the way to the end. So it should look like this right here. All right, so now if I rearrange, I get this equation that the displacement is equal to the initial x velocity times the total time. And that gives me a total of 60.8 meters. So that's how to solve these problems. Remember that you just have to follow the steps. The first thing you have to do is draw the thing out, right, just like before. And then you take this velocity vector that's at an angle and you have to break it into your x and y components, right, to get the different dimensions. And then from there, it's just like solving the other projectile problems. We get the time first, right? Use the time to the top, double it to give you the total time, and then you can go solve for either the height or the range. Okay.